What's up, everybody? Welcome to J5 Welding. This is my first video on the J5 Welding YouTube channel. So we're just going to be giving you videos of welding and fabrication that I do around here in the shop. We pretty much do everything: aluminum, stainless, carbon steel. So check us out and stay tuned. We got a pretty good build going on this morning, and so here we go. Let's build it. All right, guys, this is what we got going on today. So we got us a pull behind grill, and today what we're going to be doing is we're going to be fabricating the customer a new grill top. If you look and see, it's pretty well rusted out. And it's also warped. See how it's starting to rust through right here. It's got a big valley right here. And the frame is bent up right here. And so anyway, we're going to fabricate a new grill top for the guy. Got some new expanding metal here. We're going to lay out a new frame, cut all the parts, get it over here on the table, and we're going to put it together, weld it, put a new top on there. These brackets right here. So how this works, we've got this cable, and this cable attaches right here, and this piece of flat bar rides in the groove of these two pieces of square tubing, and that enables him to pick the grill top up or lower it to adjust his cook height, and it's done by this wheel right here. So what we're going to do also is, I noticed on these brackets that they're rusted too, and they're starting to flake off. So probably going to fabricate him a new set of brackets as well. Thought I was going to be able to just cut these off and refurbish them and use them again, but I don't think I'm going to be able to, because I don't know if you can see right there, but see, it's starting to flake off. It's rusted pretty bad, so we'll go ahead and replace these two. All right, so there we have it. Let's get started. All right, something I want to point out real quick. Whoever fabricated this the first time, or originally, when they cut the square tubing, they butted the square tubing up. So this is this is the 60, so this grill is 64 by 34, okay? The 34, they've got buttoned up into the side of your square tubing, just like so. And they did not 45 the two pieces to where it would come together and to be welded solid. So now you got this hollow tube running all the way down on both of these. So what happens with that is now you're allowing moisture to collect inside the tube, which causes the inside to start to rust out, and then that's when you start having failures like this right here. Underneath here is completely rusted out. So what I'm going to do whenever I refabricate this is we're going to 45 all the corners and put them together, weld them all the way around to where you get a sealed piece, or the sealed frame all the way around. That way we don't run into the inside rusting in the future, okay? Just wanted to point that out real quick. Okay, so the machine that I'm using is the Everlast Power iMig 275P. P stands for pulse. We can set this machine up for pulse function for MIG welding, but for today I'm not going to be using that. We're just going to be using the standard MIG function. And so we're welding 1-inch square tubing, 16 gauge thickness. I have my machine set up at 20 volts and 360 inches per minute. With it being 16 gauge, I'm probably going to dial this down probably to around 19 volts. I think I have a preset. Yeah. So I have a preset at 19 volts, 172 inches a minute. This is for whenever I run 035 diameter wire, but currently I have 030 diameter wire, so I'm going to have to run my inches per minute up a little bit. And I'm thinking around, we'll try 224, see how that runs. May have to adjust it a little bit, but this is my setup. I do not run 75-25 gas. I run 92.8, which is 92% argon and 8% CO2. I like it a lot better because sometimes I have to run spray arc for heavier and thicker metals, and this gas here will do spray arc as well. So anyway, I like using this gas versus the 75-25. 75-25 is good too. I've used it for years, and I don't know, I just started using 92.8 and I like it a lot better. All right, so we'll get back over here to the table and we'll start laying out our frame. All right, here we are now with the frame. It is complete. And the reason I grinded this side here only is because this is where the expanded metal is going to lay, and we want it to be able to lay flat all the way across the frame. And I ground around the corners here just to round them off some. That way you don't have any sharp edges, and that way nobody will cut themselves while, you know, loading or unloading meat off of the frame or off of the grill top here. So now I'm going to lay the expanded metal up here, and I'm going to get a measurement off the frame, and then we'll cut out the expanded metal, lay it on top of here, and weld it on, and then we'll move on to the brackets. The other welding machine that I have is this Everlast Power Pro 256, and it is a multi-process machine. I can do plasma cutting, arc welding, and TIG welding all in one, and we can achieve that by setting the machine up for whatever process that I need to do. On the TIG function, I also have the pulse function for TIG, and I can weld AC and DC on this machine, which means I can weld stainless steel, steel, and aluminum. So currently I have the machine set up for TIG welding, and what I want to do now is set it up for my plasma cutter, because using the plasma cutter to cut metal is a whole lot quicker and easier than using a torch. So what I'm going to do now is, if you'll see here, it's set up for TIG welding, and I'm going to make sure that the pulse function is off. I want to go down here to my gas flow and make sure that the post flow is turned all the way up. That way, when I finish plasma cutting, it will give me about 25 seconds of airflow through the nozzle of the plasma cutter. That way it will aid in cooling the plasma torch. Okay, so we're going to keep it in 2T or pedal. We're going to swap this over to DC. All right, and you can see here we got TIG, cut, and stick. So now we're going to turn this switch to cut, and then we're going to come over here and we're going to disconnect our DINS connector for the TIG welder, disconnect our gas port for the TIG welder, and then we're going to take our DINS connector, plug it into the machine, and then we've got our control lead that we're going to hook up. Then we have our pilot arc wire that needs to be connected. Let it go in there like that. All right, then we'll hook up our air line and our gas outlet. All right. Now we'll come back here to the machine, take our cap off of our air regulator, and then we'll come over here to the air regulator from the main supply, and we will set it on 100 PSI. All right. And take our air hose. All right, just like that. We'll turn our machine on. All right, so our amperage settings on our plasma cutter, we can go as low as 20 to 22 at a max of about 63. So since this is 11 gauge material on our expanded metal. Probably going to go around 30. That should give me a good clean cut. And check our air pressure. I'll come over here to my manifold, turn the argon off, turn the air on. And we got pressure. And the radio light is on. And we're ready to cut. All right, now we got our expanded metal cut out and we got it laid up here on our frame. And we got it pretty much in place. So what we're gonna do now is we'll go around and I'll tack the corners, a couple of tacks in the middle, a couple of tacks along the braces, a few tacks on the back side, corners again, kind of in the middle. And once I get all that tacked, then I'll start about every third intersection. I'll make a weld, about a 1-inch weld, all the way down. Same here on our cross members. About every third, fourth one, I'll weld down it. Same thing on the ends. About every fourth, fifth one here, I'll weld it all the way down. Same thing on the back and all the way around. That way it'll be on here good and sturdy. It won't give in the middle. What I've noticed a lot of times is guys will, well, I say guys, manufacturers, they'll only put maybe a tack in a corner, one here, one there, one there. And I see a lot of it on utility trailers. and I've repaired a ton of utility trailers where the expanded metal has pushed through the frame and has bent, and I had to cut it all out and replace it with new. And what they don't do at the factory is that they just don't put enough weld on the expanded metal to the frame that they're welding it to. And that's what causes it to push through. I just like to add more weld, man. It makes it more durable, makes it last longer, makes your expanded metal, the space in between the end of the frame and the cross member, it's more rigid. It doesn't have as much give. So anyway, that's what we're going to do here, and we'll be finished, and then we'll jump over here and get measurements for our guides, and we'll get those cut out and prepped, tacked together, and then we'll come over here and we'll measure the width of our frame, get our center, we'll tack it and weld it here, and then we'll get this old one off, get it out of the way, take our new one, set it in place, hook our cables up, and we'll be ready to go. All right, so I've measured our guides, and they are 8 inches long, 2 inches wide. And we're going to come in 2 inches from the middle, which is 1 inch to the center, and then we'll cut 2 inch by 1 inch section out. That way that will fit over our tubing. And then up here in the corner, we got a 1/2 inch in on both sides to our center point for our drill hole. We'll use a 5/16 bit. So we're going to lay these out, cut them, and get these tacked and welded together. And then we'll get our center on our frame. Then we'll put our guides here, tack and weld them in place. All right, so I got a piece of 3/16 thick plate set up here on the table. And what I'm going to do is I've already made a 2 inch cut right here on a previous job. So what I'm going to do is just continue this cut all the way down to 16 inches. because I got to have 2 guides and they're 8 inches long. So let's go ahead and mark our 16. Okay. All right, there's our 16 inches right there. So I've got my combination square set up at 2 inches. Actually, I got it set up to 1 7/8. And the reason I got it set up at 1 7/8 because you have to take into account the width of your soapstone, which is about an 1/8 inch thick. All right, so once I set combination square on the edge of the metal and put my soapstone to the edge and make my mark, then when I measure from the end of the plate to the mark, you have 2 inches. Okay, so we're going to go ahead and mark this all the way down to our 16-inch mark. I'm having to work around my camera. Okay. Slide this over a little bit. Now. All right. Okay. So now we're going to cut this out. And then I'll measure 8 inches and cut this in half. Probably just take it to the chop saw and cut it. But I will cut this section out here with a plasma. And then we'll notch out our ends. And then measure for our drill hole. And then we'll drill a hole. And I'm going to take my grinder and round off these edges too. And once we get this cut out and set up and get the holes drilled, then I'll measure for the gussets. And I'll make the gussets and we'll weld them onto the guides. All right, I'm ready to cut our 2-inch piece out. What I got here is just a piece of scrap aluminum square tubing. I'm going to use this as a guide for my plasma cutter. And on the plasma cutter, I have this little attachment here. It's also used as a guide to make straight cuts. So I want to show you real quick. If you look on the back side of this piece of plate that I cut out, you'll notice this molten slag material right here that's stuck to the metal. This is called dross. Okay, this is the metal that is melted and blown out of the cut whenever you're making a plasma cut. Okay, and it just basically melts and just rolls over and sticks to the bottom of the plate. And so what I'm doing now, I'm taking my little scraper and just scraping all that off. I could use the grinder, but those grinder discs are about $12 a piece, and so just to save time and save on consumables, it's just as quick to knock this off and then take my grinder and lightly go over it, knock off any of my scraper didn't knock off. See, just like that. Real easy to get off. It's not like it's welded on there, so now I'll just take the grinder and clean up my edges and we'll move on. All right, so now we're gonna notch out our 2" by 1" cut. This piece will sit on top of the frame like that, and then we'll make the gussets on each side and do our drill hole and weld it to the frame. There's our 1/2" marks for our drill holes. So now I'll take a center punch. And right there where the crosshairs meet, we'll take a center punch and make a little divot. And then we'll go into the drill press and make our holes. Just like that. Alright, we got the guides cut, got the gussets cut, got everything tacked and welded on. Same thing here. So now we're going to take the old one off, put the new one on, and hook the cables up and make sure she goes up and down like it's supposed to. everybody. Turn the wheel and see what happens. Look at there. Comes up nice and even. And pull the lever. And there she goes. Nice and smooth. All right, y'all, we finished with the grill top, and I think the customer's gonna be pleased with that. So appreciate y'all tuning in to J5 Welding. Hopefully we'll have some more videos coming. So yeah, if you're in South Alabama, need something welded, give me a holler. All right, J5 Welding, here we go. Appreciate y'all. See you later.